the electron dot notation that you took notes on, the last video that you watched. The electron dot notation, when we talk about this, we are strictly dealing with the main group elements. Now, just a refresher, what is a main group element? What is a main group element, Justin? The P block and the S block. Excellent. So we're only dealing with the S and the P's when we're talking about these. What we do is we represent the valence electrons with dots. Go ahead and take out your periodic table so we can do some looking at that. On our periodic table, we know that group 1 and group 2, the alkali metals and the alkaline earth metals, are the S block. Okay? So the alkali metals are S1, the alkaline earth metals are S2. So they would have 2 electrons if both of those were filled. When we get into the P block, we're looking at, let's see, numbers 13 through 18. Now, if you look, let's say, at the carbon family, okay? So group 14 down, the carbon family. How many valence electrons? And what valence are? The outermost energy level, okay? If you look, carbon would have 4 electrons on its outermost energy level. Okay, 4 electrons. So each group has a certain amount. How many valence electrons would silicon have? 4. How about, what's the next one? Germanium? 4. Tin? 4. Lead? 4. That whole family has the same amount of valence electrons. It would be 4. So as we're looking at these S and P of the main group elements, we can know how many valence electrons based on where they're at on the periodic table. Now, as I am filling in my dot patterns, there's a specific order that we undergo our dot patterns. The first dot goes right where the number 1 is. The second dot, then the third, fourth, and fifth. This is a little bit different, as you're going to see by the next one, all right? As you're going to see by the next slide of why we put 3, 4, and 5 at different sections, because it's representing different orbitals. Dot 6, dot 7, dot 8, if we have a full outermost energy level with 8 valence electrons. Those would be the noble gases, okay? Those would be the noble gases. Now, as we go through the representation, dots 1 and 2 represent the s orbital, okay? At the top would be 3 and 6 up at the top. That represents the p sub x orbital. Dots 4 and 7, which would be to the left, represent the p sub y orbital. And dots, let's see, what are they? 5 and 8 down at the bottom represent the p sub z orbital. So that is the reason. If you remember, okay, if you remember when we were filling those p orbitals with arrows, we had to have 1 on each orbital before we doubled them up, didn't we? Remember doing that? That is the reason that we go, 5 up here, or let's see, 1, 2, 3, then 4, then 5. We put 1 on each of those sides before we double them up. Okay? Now let's look at just the very simplest of our electron dot notation is hydrogen. So, how do we do these dots? Well, we start off, okay? I look and I say, okay, if I am writing my electron configuration for hydrogen, I know that hydrogen is 1s1. Okay, 1s1. So I know that it has only one electron. So when I am writing my electron dot notation, I have hydrogen, and I'm going to have one dot. Where am I going to put that one dot? Top right, right there. So that is the electron dot notation for hydrogen. That's simple. Beryllium. Okay. Beryllium. Look at your periodic table. I know that my electron configuration for beryllium is 1s2, 2s2, correct? So, if I am looking at this, 1s2, 2s2, what is my outermost energy level? Okay, what level is the outermost of those? How about level number 2, correct? How many electrons are on level number 2? There are 2. So as I am writing beryllium, I have my Be as my symbol. I put my first dot where the number 1 would be. I put my second dot where the number 2 would be. So that is the electron dot notation for beryllium. Nice and easy, isn't it? Sulfur. Okay? Sulfur. Go ahead and write down the electron configuration for sulfur. You should know this. So before I pop it up there, go ahead and write the electron configuration for sulfur. Your electron configuration for sulfur should be 1s2, 2s2, 2p6, 3s2, 3p4. Correct? Now, what I have in red up there, okay? What I have in red up there are the valence electrons. Remember, valence electrons are the electrons that are on the outermost energy level. How many electrons do I have on my valence level here? 2 and 4 is 6. So how many dots am I going to have? I'm going to have 6 dots. So here's sulfur. I dot 1. I dot 2. Here's 3. Here's 4. Here's 5. Where do I put the next one? On the top. There is 6. So my electron dot notation for sulfur is right there. Questions for me on sulfur there? Now, once again, let's write our electron dot notation. Go ahead and do krypton. We're getting a little farther down the table. Go ahead and do krypton, and then we'll work it ourselves. So write the electron configuration for krypton. All right, my electron configuration for krypton should be 1s2, 2s2, 2p6, 3s2, 3p6. 4s2, 3d10, 4p6. Agreed? So here is my electron configuration for krypton. Now, why I wanted to show you this is because what is my valence level? What is my valence level? 4. My outermost energy level is 4. See how we've got 3D sandwiched in there. don't we? Remember, when we're doing electron dot notation, we are only dealing with main group elements. So are the D's the ones that go in there? No. Okay? They do not. So as I'm looking at this, how many valence electrons do I have? 8, correct? 8. And I should know that because all of my noble gases, group 18, all of my noble gases have full outermost energy levels, don't they? Okay? That filled outermost energy level will fill up the S and the P's. So, as I look at krypton, I am going to have dots. 1 and 2, dot 3, dot 4, dot 5, dot 6, dot 7, and I will have a filled outermost energy level with 8 valence electrons for krypton. Any question? Okay, ladies and gentlemen, that is